Hello and welcome to the Portrigger Academy SQL injection series here on CTF Security. I am your host Olajide and I am thrilled to kick off this series dedicated to demystifying SQL injection. Before we begin, consider hitting that subscribe button and ringing the notification bell so you won't miss any crucial insight, challenges and hands-on practical experience on this channel. In today's episode, we're laying down the theoretical groundwork. I will introduce you to SQL injection, its impact on system, how to detect it, and most importantly, the method to mitigate against SQL injection. This is just the beginning, as subsequent episodes in this series will be packed with hands-on practicals, utilizing Portrigger's cutting-edge labs. If you're new here, welcome aboard, and if you're a seasoned viewer, welcome back to the channel. So without further ado, let's get started. Before we begin to dive into what an SQL injection is, it is necessary we understand what SQL means. SQL means Structured Query Language, and it is a programming language used for managing and manipulating relational database. It provides a standardized way to interact with databases itself. So what this is basically saying is, with SQL, we're able to interact with database directly. We could perform functionalities such as creating the database itself, retrieving data from the database, updating data to the database, and even deleting data from the database. Now that we understand what SQL means, let's talk about the vulnerability that is associated with SQL. And that will be SQL injection, which is a hacking technique where malicious SQL code is inserted into user input, exploiting vulnerabilities in a website database. So what this is saying is, we have a database of a web applications which informations are originally stored, and there's a query that is meant to retrieve information from that database. Now, if an attacker, one way or the other, is able to manipulate this query, this could make the database to behave in an unintended manner, which can lead to a lot of different impact that we're going to be discussing in this video. Now, let's take a look at a very simple scenario here. We have our attacker sitting here, and our attacker wants to communicate with the database that is here. There's a login form here. Possibly, it could be a login form. It could be just a search field where we're able to retrieve any kind of information from the database. Maybe search for product ID of data within the database, or search for a particular item we want from the database. Now, if an attacker is able to submit a malicious query like what we have here, so let's just go through the query we have here. So we are selecting the name column, the description column from the product table where category equals to gift. So what this is basically going to do, this part of the code is not malicious. What it's going to practically do is go into the database and search for product where categories equals to gift, and it's going to output the name column, the description column from the product table. Now, if an attacker is able to break this application and combine it with another query using the union statement. So for example, let's say the union statement is being appended and we're now having select username, password from user. Then we're commenting other parts of the query. So what this is basically trying to say is, the application is going to retrieve the first query, which is all products that has the category gift, and then it is also going to retrieve username and password from the users table. So we are retrieving two kind of information here: the product information, which is the product table, and the users table. And this could be very disastrous because running this code would probably give an attacker all the list of password within that particular database. And this is just the simple query that we have here. Now let's talk about some certain scenarios we could have SQL injection. The first one is the online shopping cart. So imagine you buy an item online. SQL injection could occur if an attacker is able to manipulate input field, just like what we've seen in the previous slide. So for example, an attacker is able to manipulate the username or the product search to gain unauthorized access to the entire database. And this could be very, very disastrous. Secondly, we could have a scenario of a login form. So picture a login page where entering admin as the username and a specific SQL code grants access to the attacker. SQL injection here involves injecting code instead of a valid login. So just imagine a situation whereby an attacker does not have to have your password in order to log in your account, just your username and a very simple SQL query statement, and it gives attacker access to your account. So this could also be very, very disastrous, and we'll be talking more on this later. So let's jump right into types of SQL injections. We're going to start with the different categories. There are three basic categories of SQL injection. We have the inbound SQL injection, which is commonly referred to as the classic SQL injection. We also have the inferential SQL injection, which actually can be referred to as blind SQL injection. And lastly, we have the out-of-band SQL injection. So now let's take a look at the different definition of these categories of SQL injection. So first of all, in the inbound SQL injection, attackers is able to directly retrieve data or causes error message using the same communication channel they use to inject SQL code. And these categories of SQL injection can include the error-based SQL injection or the union-based SQL injection. So we are coming down to explaining these two different types of inbound SQL injection. Now let's move to the next category, which is the inferential SQL injection. In the case of inferential SQL injection, attackers is able to predict success or failures of injected SQL query based on the application behavior. Now this behavior could either be based on time delays within the application or based on certain logic within the application. Then lastly, we have the out-of-band SQL injection. In the case of out-of-band SQL injection, attackers are able to retrieve data using a different communication channel, unlike the inbound SQL injection. Now let's take a look at the different examples of these categories of SQL injection. So we're starting with the error-based SQL injection. In error-based SQL injection, it involves injecting code that intentionally generates errors, revealing information about the database structure. Attackers is able to accomplish this task by using different methods, such as imputing different special characters, trying to break the application to generate an error message. We also have another category which is referred to as the union-based SQL injection. In the case of a union-based SQL injection, it involves using a union statement to combine the result of an original query with a malicious query. In this case, we're able to retrieve additional data beyond what was expected in the original query. Now, let's go to the inferential SQL injection, which a typical example is the blind SQL injection, which is another name for inferential SQL injection. In blind SQL injection, it is a type of injection attack that asks the database a true or false question and determine the answer based on the application response. And this could be in two categories, which are the Boolean-based blind SQL injection or the time-based blind SQL injection. So let's talk briefly about the Boolean-based blind SQL injection. This involves injecting code that relies on the application behavior changes to infer or to predict information without directly manipulating the query logic within the application. And we're going to be seeing some example of this Boolean-based SQL injection in the exploitation phase in this video. We also have the time-based SQL injection. This involves injecting code that introduces a time delay, allowing the attacker to predict if the injected condition is true or false based on the application response time. Now let's move to the next section of this video, which is how to find and exploit SQL injection vulnerabilities. The first thing we need to do is to map out the application in order to discover the different input field within the web application. In this case, hackers probe input field like search bar, login panel of the web application by entering SQL command to see if the system responds unexpectedly. An attacker can also find SQL injection by entering a single quote or double quote within the web application to break the application to generate error message within the database. An attacker can also find an SQL injection by performing SQL specific syntax evaluation. Testing with SQL specific syntax that evaluates to the original and a different value helps identify whether the application processes input as a data or execute it as an SQL code. We can also find SQL injection using Boolean condition, and this involves using a logical operator and a condition that always evaluates to true or false. Boolean condition looks for differences in the application responses. And lastly, we can find SQL injection by using time delays payload. These payloads are designed to trigger time delays when executed within SQL query. Now let's take a look at the different types of SQL injection, their payload, and their detection mechanism. First of all, we have the classic SQL injection, and this involves inserting malicious SQL code into user input field to manipulate the structure of the original SQL query. Now let's take a look at this payload here. We have a single quote within the web application which closes the initial string that attempts to break the application. Then we also have or 1 equals to 1, which is the case of a Boolean based SQL injection, which is we are trying to inject a logical operator and a condition that always evaluates to true. Then we also have the dash dash, which is the double hyphen, which starts a comment, making the rest of the query ignored, meaning that any query that comes after the dash dash or the double hyphen will not be executed. For the detection method, observe the changes in the application response, unintended data retrieval, or different behavior. These are some of the things that this payload can result to. We also have another type of SQL injection, which is the union-based SQL injection. In union-based SQL injection, it involves injecting a union statement to combine the result of the original query with those of another query. It retrieves additional data beyond what was expected in the original query. Now, let's take a look at the payload that we have for this type of injection. First of all, we are closing the initial string of the SQL query. Then we are using the union statement to combine the initial query that we have with the query which the attacker is trying to submit, which involves select username, password from admin. Then we are going to break other parts of the query by starting the comment. So to just explain this, so we have a single code that closes the initial string. We have union select username password from admin, which append result from another query, which is the previous query we have. Then the double hyphen start a comment, making the rest of the query ignored. In order to detect SQL injection in this scenario, observe if the application returned data not originally present, suggesting a potential union-based SQL injection. There are some conditions that needs to be satisfied in order to exploit a union-based SQL injection, and that involve the vulnerable query must contain a union statement. The number of columns selected in each branch of the union must match, and we're going to see how to confirm this. And lastly, the data types in corresponding column must be compatible. So if you want to extract a string data, both table must contain string data type. So you can't combine an integer with a string data type. That is just going to throw up an error. So let's take a look at a very basic way of exploiting a union-based SQL injection. So now we have an original query which says select title and cost, which is the title column and the cost column from the product table where ID equals to 1. This is a very basic SQL query that is not malicious, just retrieving information like the title and the cost of a product which the ID is 1. If an attacker wants to perform a union-based SQL injection to retrieve data from another table within the database, remember we are dealing with the product table now on this query. Now, the first thing an attacker wants to do is to determine the number of columns within the web application. And there are two ways of doing this. We can either use the union select null, or we can perform the order by injection types. So we are going to start by injecting a series of null value incrementally until there is no error. The goal is to identify the number of columns in the original query. So in order to figure this out, we're going to select the first one, which is union select null. We try this. If the application generates an error, we try the next payload, which is union select null null. Then we comment out other part of the query. Then we try the third one until there is no error. So once there is no error, we know that we have actually found the number of columns. So now we're going to assume that the injection is successful with two null value, indicating that there are two columns in the original query. Now, the next thing we are going to do when we have figured that out is to determine data types of the columns. So next, we are going to probe each column to test whether it can hold string data by submitting a series of union select payload that place a string value in each column in turn. And in order to do this, we can issue the payload, we can close the initial query, then we supply the union select, then we pass a string. It doesn't have to be A, it can be any string character. Then we pass it into null. This is for the first table and this is for the second table. If an error occurs, e.g., conversion failed when converting variable character value, the string number we entered, to data type int, it suggests that the injected string, which is the A string, is not compatible with the data type expected by the column. Remember the policy here, let's just go back to that. The policy here says that the number of the columns selected in each branch of the union must match, and secondly, the data types in corresponding column must also be compatible, meaning that we need to have string in order to concatenate those string information together to output it using our payload. Let's assume that both columns can hold a string data. So we have the first column holding string information, the second column also holding a string information. Then now we can craft the final payload. So let's say our payload is this way. We're going to break from the initial query. Then we use the union select statement to select username and password from another table, which is users table. Then we comment out other part of the query. Now our injected code will look like this. Remember, we have our initial code, which is select title cost from product, where ID equals to 1. Now the injected query will now become select title cost from product, where ID equals to 1, union select username, then password from users table, then comment out other part of the query. So this means that an attacker is able to extract the title, the cost of product ID 1, and is going to concatenate it with all the username and password within the database. And this can be very, very disastrous. Now, this is how our output is going to look like. If the injection is successful, the output might look like this. And we have our product, which is, for example, we just have two products within the database, product A and the cost, product B and the cost. We also have John, which is from the users table, and we have Charles from the users table and their corresponding password. Now, if we want to understand what the second law here or policy here is talking about, that the number of columns selected in each branch of the union must match. So what this is basically saying is, let's say the product table has 3 columns and the users table have 2 columns. If you try to combine them, you definitely get an error message. So you have to be certain that the product table that you want to retrieve the first data from and the users table which you want to retrieve the username and password from both have the same numbers of columns within the database. Now let's move ahead. We also have an error-based SQL injection. Error-based SQL injection involves injecting code that intentionally generates errors, revealing information about the database structure. Now let's take a look at this typical example. We have an original query that selects everything from product, where category equals to gift and release item equals to 1. Now, the release can either be 1 or 0. In this case, if the release of the item is equals to 1, that means the item is visible to the user, but if it is 0, it means that the item is unreleased, which is not visible to the user. So one thing an attacker can do in the case of an error-based SQL injection is to inject a single quote or a double quote within that particular search field. And this can modify the query. Now it's going to look this way. Select everything from product while category equals to the first quote, then the injected quote. So instead of entering gift, an attacker will just enter a single quote within this quote that we have here and other part of the query. And this can cause the application to generate error message on the screen, which is going to reveal the structure of the database, including the type of server being used by the database. Now let's take a look at another types of payload that we have. We can also inject a single code or 1 divided by 0. Then we could comment out other section of the code which involve the and release equals to 1. Now let's take a look at the payload explanation for this error-based SQL injection. First of all, we are injecting a single quote which closes the initial string. Then we send the 1 divided by 0 using the OR logical operator to create a division by 0, revealing details about the database. Then the double hyphen start a comment, making the rest of the query ignore, just like we explained earlier. In order to detect this type of injection, observe the error message returned by the application indicating a potential error-based SQL injection. Now let's talk about the other type of SQL injection, which is the blind-based SQL injection. Blind-based SQL injection or the Boolean-based blind SQL injection involve injecting code that relies on the application behavior changes to predict information without directly manipulating the query logic. And let's take a look at a typical example here. We have a web application with the domain name insecurewebsite.com/product, which is the endpoint. Then we also have the categories equals to gift here, meaning that a user is trying to search within the database for an item of the category gift. Now the query at the back end is going to look like this. Select star, which is everything, all the columns from product where categories equals to gift and release equals to 1, just like the previous example we just saw on the error-based SQL injection. Now the payload we are going to send is going to look like the classic payload we sent earlier, which is going to be a single quote to close the initial string within the application. Then we are going to have the logical operator 1 equals to 1, which is a statement that always evaluates to true. Then we're going to have a double hyphen to comment out other part of the query. Now this is how our payload is going to look like. Select everything from product where category equals to gift or 1 equals to 1. Then we comment out the release item. So in this case, we're able to view all the data, including the release and unreleased item within the database. And this is the payload explanation. In order to detect, in order to detect this type of SQL injection, we observe different application behavior based on the injected conditions, such as varied error messages or responses. Then we also have the time-based blind SQL injection. This involves injecting code that produces a time delay, allowing the attacker to infer if the injected condition is true or false based on the application response time. And this is a very typical example. So let's say we have a payload that we injected a single code with a logical operator, or if 1 equals to 1, which is a condition that always evaluates to true, then sleep for 5 seconds. So if this application is being executed and the application is able to have a time delay of 5 seconds, this is an indication that that application is vulnerable to an SQL injection. So let's look at this payload here. We have the single quote, or if 1 equals to 1, sleep, then we have our 5 as the argument. Now for this payload explanation, we have the first single quote which closes the initial string. Then we have if 1 equals to 1, sleep 5 seconds, which introduces a time delay if the condition is true. And then 1 equals to 1 is always true, meaning that the statement always executes where it's going to have a delay of 5 seconds. The double hyphen starts a comment making the rest of the query ignored. So in order to detect this type of time-based blind SQL injection, observe the delay response in the application indicating a potential time-based SQL injection. So now let's talk about the last type of SQL injection, which is the out-of-band SQL injection. And this type of SQL injection involves injecting code that triggers interaction with external systems such as DNS requests. Now let's take a look at a very typical example of a simple query which just selects everything from product where category equals to gift and release equals to 1. Now we could have two different types of payload. So this is the first payload here and this is the second payload. So first of all, we are selecting everything from product where category equals to nothing. Then we are using the exec function to execute a standard stored procedure. And then we are executing a system level command, ns lookup. Then we supply our domain name here. Then we can comment out other parts of the query. Now, if we want to do a simple explanation, maybe starting from the exec, so the exec xpcmd shell ns lookup your domain.com trigger an out-of-bound interaction. The double hyphen starts a comment making the rest of the query ignored, meaning that the and release equals to 1 part of the query will not be executed. So the same way, we are still having the same command here. We break using the single quote, then we issue the logical operator with a condition that always evaluates to true. Then we perform a stack query here by using the exec function to execute the xpcmd stored procedure. Then we supply our command, which is the ns lookup your domain.com. So basically what this domain is going to do is to just run ns lookup with the domain name you supplied in your query. In order to detect this type of SQL injection, monitor external interactions such as the DNS request triggered by the injected payload. So those are like the basic types of SQL injection, and we're going to be talking more in subsequent video where we get to demonstrate how to exploit these different types of SQL injection. Now that we properly understand the different types of SQL injection and how they can simply be exploited, let's discuss about the impact of SQL injection. The first and the most common impact of an SQL injection is unauthorized access. SQL injection can be exploited to bypass authentication mechanism, leading to unauthorized access to data. And this can go against the CIA triad, which is the availability of data, the integrity of data, and the confidentiality of data within the database. Then we also have the remote code execution. SQL injection, when combined with other functions like stored procedure, for example, in the out-of-bound scenario where we use the xpcmd shell to execute a command using the SQL query. When an SQL injection is combined with some certain functions like the stored procedure, it can lead to a remote code execution on the database. Then we also have data exfiltration. SQL injection can be used to extract sensitive data from the database. Then we also have business logic manipulation. By exploiting SQL injection, attackers may manipulate the underlying business logic of the application, making the application to behave in an unintended manner. All right, so let's talk about the different testing approach of SQL injection. We have two basic testing approach. We have the black box testing and we have the white box testing. Now, in the case of the black box testing, this simply means that we do not have access to any infrastructure of the web application like the source code of the application. The two ways I like to do this is to perform a manual testing and also perform an automated scanning within the web application. And the manual testing involving most of the things we've discussed during our inbound SQL injection and the inferential SQL injection. And this include input manipulation, error-based testing, such as trying to trigger the application to generate error message, then union-based injection, trying to use the union statement in order to combine information of the original query and a malicious query to retrieve data from the database. We could also perform some automated scanning using some known tools like the SQL map or Observe. We can also use Bobsu to perform dynamic testing within the web application. These tools can automatically detect and exploit SQL injection vulnerability, providing detailed reports. Now, in the case of the white box testing, this is when you have access to the database, you have access to the log file within the application. The first thing you want to do is to perform a code review. And this involves examining the source code to find areas where user input is used in SQL queries. We can also ensure proper input validation, sanitization, and parameterization technique are employed within the web application. Then we can identify and rectify instances where user input is directly concatenated into SQL statements. Another way we could approach this testing is static analysis, and this involves using automated tools such as SonarQube, Checkmarks, Fortify. This tool can automatically scan the code base for SQL injection vulnerability, analyze the source code without executing the application, identifying potential coding practice leading to the SQL injection itself. And lastly, you could perform a dynamic analysis. Perform a runtime testing to trace the flow of user input through the application. Monitor SQL query during execution to confirm proper sanitization and separation of user input from the statement. And a very simple tool that can be used to do this is the Bobsuit application. We're going to be seeing this on the practical videos of this series. Let's talk about the different ways we can mitigate against SQL injection, and one of the most common and effective way of doing so is by using a parameterized query. A parameterized query ensures that user input is treated as data and not executable code, preventing the injection of a malicious SQL code. What this basically means is that we are separating SQL code from user input. And now let's take a look at a very simple PHP code that illustrates this. Now we have a variable declaration, which is the statement. Then we have the prepare method issuing a query, select everything from user where user ID equals to a placeholder. We're going to be seeing explanation for this. Then we are using the bind parameter method in order to issue two parameters, which is the I and the user ID. Then we executed the query. Now, if we go to the explanation part here, we have the first part, which is the prepare method, which is this entire line here. This method is used to create a prepare statement. Prepare statement separate SQL code from user input by using a placeholder. In this case, we are using question mark as our placeholder, and later we're going to be replacing this placeholder with a variable name that we're expecting the user to input data into. Then next, we have the bind parameter. This method bind variable to the placeholder in the prepare statement. Now, this is taking two values or two parameters or two arguments. We have the I, which is specifying the data we're expecting from the user is of an integer type. And then we have user ID, which is going to be the username for the application or the username that we're expecting data from. Then we have the statement that also executes the particular query we have in our prepared statement. Now, this SQL query is now resistant to SQL injection because the user input is treated as data and not executable code. So now let's take a look at another way of mitigating against SQL injection, and this is input validation. In input validation, we only allow expected and valid input, rejecting any input that does not adhere to a predefined criteria. Now let's take a look at a very simple example here. We are using a variable declaration here equals to filter var, which is actually a PHP function. Then we are supplying two arguments, which is the user ID and the filter underscore validate integer. Then we are also having a conditional statement that checks if the user ID equals to false and if the user ID equals to null. Now let's go to the explanation part here. We have filter underscore var is a PHP function used to validate and sanitize data. It takes two parameters, just like I've explained earlier, the variable to be filtered, which is the user ID in this case, and the filter to apply, which is the filter underscore validate integer. What this is actually saying is that whenever the user entered any value that is not an integer, simply reject that. So we are only specifically allowing an integer value into the database. And then we also have explanation for the filter validate integer, which checks if the variable is an integer. If it is, the function return the integer value. And lastly, we have the part here that makes the check. And what this part is actually going to do is going to check the value that is being supplied by the user and check if the ID is equals to false. And then it's going to also check if the ID is equals to null. If these two criteria are met, invalid input will be generated. But if they are true, the code will be executed, or the query is going to be executed. So that is how input validation works. We also have another method of mitigating against SQL injection, and this is called whitelisting. Whitelisting allows only approved safe input and blocks anything else, preventing security threat like SQL injection by strictly defining what is allowed. It enhances overall system security by limiting accepted input to known and secure elements. Now let's take a look at how this can be implemented. We can have a function declared with a function name getUserById, and we have a parameter as an argument, which is the user ID. Now if we want to perform a whitelisting to only allow numerical character, what we can do is to send an if statement. We declare a function which is called the pregmatch, and we are passing two arguments, which is one of the arguments being supplied to the getUserById, which is the user ID, and the second is the regular expression to match only numeric character. And I'm going to come back to this particular regular expression. Then lastly, if this condition is met, return false. Now let's take a look at the proper explanation of what this simple code snippet is doing. Pregmatch function checks if the user ID matches the specified whitelist pattern, which is this particular regular expression that we have. The pattern is this, which ensures that only numeric characters 0 to 9 are allowed in the input. If the input contains any character other than numeric character, the function returns false, indicating invalid input. So if we do not match this function, remember we have a negation here, which means that if we're not able to match this particular regular expression that we have here, it should return false. Now regarding the regular expression that we have, first of all, we have the slash, which just indicates the start of a regular expression. Then we have the caret symbol, which asserts the start of the string. Then we have the 0 to 9. This is basically telling us that whatever value that we are expecting should fall between the range of 0 to 9 and nothing else. And then we also have the plus, which is a quantifier indicating that one or more numeric digit must occur. What this is basically saying is we could have a continuous numerical data, maybe 2, 3, 5, 7, 4, depending on how many numerical value the user decided to input into that particular input field. But mind you, we cannot have anything other than numeric character. And then lastly, we have the dollar symbol, which asserts the end of the string. So basically, if a user tries to enter a quotation as the input value to the application is going to return a false statement because it has goes against the whitelisting that we set up within the application. So that is that about whitelisting. We could also use firewall to mitigate against SQL injection, and this is a very simple example of mod security firewall rule. And this is the basic explanation of this firewall rule. The first part, which is the sec rule argument, what this is practically saying is it looks for specific character associated with SQL injection in the request parameter. Then we have an ID, which is the unique ID, for the rule. We have deny, which is the action that will be taken if the rule matches. In this case, denying the request. And lastly, we have the message that will be displayed on the screen, which is SQL injection attempt. So this is a very basic rule. We can have much more complicated rule other than this. Then the last method of mitigating against SQL injection is by using the least privilege rule. And this has been segmented into two categories. We have the limited access right and the separation of duty. Now let's start with the limited access right. In order to perform this type of mitigation, we need to ensure that database users have the least privilege necessary to perform a certain task. This is meant to reduce the risk within the database. In this case, users should only have the permission required for their specific task, such as selecting or retrieving information from the database, inserting or updating data into the database, or deleting information from the database, and nothing more. For the separation of duty, we need to avoid using single high privilege user for all database interaction. Instead, we can assign different users with specific role and permission based on their task. For instance, a user that is responsible for read operation might not need to have write or delete permission within the database, and this is meant to enhance the security of that particular database. Now, let's talk about the tools that we can use to exploit SQL injection. And one of the most common tool is the SQL map, which automate the discovery and exploitation of SQL injection vulnerability in web application. We can also have Bob Suite, which is used to perform dynamic exploitation of SQL injection. We can also have the OAuth ZAP, which is very similar to the Bob Suite. We have Akunetics, we have Metasploit framework modules, we have the SQL ninjas, and we're going to be using some of these tools in our subsequent video in this series. So guys, that'll be all in this video. Thank you very much for watching. If you've learned one or two things, please make sure you like, subscribe, and share, and I'll see you in the next video.